And of course, the webinar is recorded. And if you would like to see the webinars at a different point, all you have to do is go into our website at solidcam.com. And I'll show this to you, in fact, right now. If you go onto our website, you'll see we have a section called Webinars. And if you go into Webinar Recordings, you can see all of the previous recorded webinars that we have over here. Okay, so on to our webinar itself. As I said, we'll be showing you, I'll be showing you actually the different types of strategies that we have inside HSS. And then I'll actually be showing you actually machining a whole part using HSS from the beginning. Now, let's first start off with this part that we see on the screen. And on this part, I'll actually be showing you some of the HSS modules and how they're actually programmed, and some of the tricks we can use to get you a different toolpath using HSS as well. Now, let's first take a look at the stock over here before I continue. And the actual stock that we have over here, if I show it to you in 3D, is the actual shape of the part, the actual outside shape. You can see that over there. And even before I start HSS, let me just machine away all of the excess material that we have over there, doing a rough cut and everything. And for that, I'll actually be using iMachining 3D. Let me delete what I have over here right now. We don't need that. I'll start from actually the beginning. So just to start off, and I'll just go into iMachining 3D. That's actually the best way to machine out all the excess material. The geometry itself in 3D and iMachining 3D does not have to be put into here, as it already took the target into the geometry. Since I defined the target, it's done here automatically. And the tool that I will be using in this particular case will be a 12 millimeter, or if I talk inch, it's a roughly just under a ½ inch tool. I'll select the tool. The levels I do not have to deal with at all. Technology Wizard, I'll be working, it's set it at a level 6. And in my technology itself, I'll be leaving wall offset, and also we have a rest rough for that material itself. Let's do the quick calculation on the part itself. And I'm just bringing this up now just to remind everyone that whenever you have a part, in any case, you always have to rough out the material, the material to get to the surface that you want to finish to at the end. And what better way to do it than using iMachining 3D to get the easiest way to create a toolpath on the part itself, plus also the most efficient way for creating the toolpath on the part itself. So we'll just finish off with the calculation over here. This will take just another moment. We'll even take a look at the toolpath, and then we'll go into the HSS on the part itself. Just give me another moment here. As you see, it's calculating down the steps. All the different Z levels are being calculated. And in a moment, we'll take a look at the simulation as we get towards the end of the calculation over here. Okay, just one more moment. Okay, we're just about done now. Okay, now if we take a look at the simulation itself, we can see that actually, let me show this with the toolpath. I believe you can see the toolpath, so take a look at the top view. You can see the actual toolpath as it's working from the outside trochoidal over there. And it's doing actually, at this point, let me just stop it over here. And you can see that it's actually creating a little bit of a moat around this area over there. By doing that, it allows for a spiral cut to be done in this area over here, because now you can go from all sides, as well as a spiral cut around over here, making for a very efficient tool cut. Note also that as it finished the step, it's now worked up on these areas before going down to the next level. Now that it's finished this area over here, it's not going down and doing the next step as shown over there. And it does this all the way down to the very bottom, leaving us with the exact material that's needed for our finished cut. Note also that these steps here are also machined up over there. It's finishing off this level up until here, and then it's going to finish off to the next level after it finishes off this side over here. This middle area over there, as well as that step over there. And we're just about basically done as it finishes off this entire part over there. Okay, so now after machining this, we're now ready for our finished cuts. Now, let's take a look now at the different strategies that we have using HSS. If I were to open up HSS, you can see we have all our strategies listed over here, whether it be parallel cuts, parallel to curve, and we're actually going to go through these and I'll show them to you. And then when I finish showing you these strategies over here, I'm going to open up another part exactly like this, the exact part where all of the operations were already done on the part, and we'll see exactly how I did that using HSS. Okay, first we have the option of parallel cuts, and let's take, for example, parallel cuts linear. Parallel cuts will actually work parallel whether on the part itself, whether it be linear, or if I chose the option of constant Z, it'll always work parallel either to the constant Z or to the linear in the direction that I tell it to work. Let's use linear, and let's, for example, use this surface over here. I'd like to machine this surface over here. So I'll just click on that surface. And let's take this surface over here as well. You know, I'll even add on this surface over here. Even this one over here, these surfaces around here, let's go all the way around. Let's take all these surfaces, in fact, and we'll work linear on all of those surfaces as I go around the part itself. Choosing all those surfaces. As you can see, no problem picking those surfaces. You know what? In fact, I'll even add, besides these surfaces that I chose over here, I'll even add these surfaces over here as well. Going around the part, basically all of these surfaces over here, this area here, I don't want to use linear for that. So I'm going to actually work on all of these surfaces, and we'll show exactly what linear does. Okay, picking all of those surfaces, we're almost done. Okay, all the surfaces I want to work on linear, I've chosen them. We're all fine now. The tool that I like to use, now, before I go there, we also have something here called defined angle. I can work 0 degrees, in other words, working only on the X direction, or I can also, if I want, let's say I want to work 90 degrees, working from this side back and forth on this area over here, working 90 degrees to my part. Okay, so I can just write in here 90 degrees. The tool that I will be using, I'll just use a simple ball end mill, excuse me. And if I go into a toolpath parameters, you can see we have our maximum step over there. I'll just leave it for now at 1 millimeter. And in our sorting, we have zigzag. Now, let's just do a quick save and calculate before we actually go into our links. And let's take a look at the toolpath that we received over here. If we take a look, you'll note it'll go actually across the part. Actually, I don't want to use solid verify. Let me just cancel that. Not use solid verify at all. And as you can see, it machined all of those, but every single time it came to a gap, it jumped up to the next area and went back down. Now, I don't want it to jump up. So what I can do very simply, if I go into my links, I'll just go into where I have my large gaps. My large gaps are going to its clearance area. So instead, I'll have that go direct to the other side. If I save and calculate that now, take a look at my simulation, you'll see now that's actually going up It's going directly across over there. Now, as far as these areas over here, those are actually between the links. The links, I'll actually change them also to be blend spline, where it actually just blends the two splines together when you have a large move between them. Again, we'll do save and calculate. Run my simulation. Now you can see we have a nice toolpath going across the part. Now, however, there is one thing I don't really like too much about this toolpath. If I take a look at the toolpath itself, you'll see that it's going from this end to over this end directly, no problem with that. But the feed that it's actually using a relatively slower feed than it would be. It's not using the actual maximum feed of the part. It's actually using the a little bit quicker than this area over here, but still a relatively slow speed. Now, note also the time that it took, 1 hour and 17 minutes. Well, that's actually a function of the feed of the tool itself. But let's try a different strategy instead of what I did right now. I'll still keep it at parallel cuts linear. If I go into my toolpath parameters and go into sorting, we have something here called cut order. Right now machine by. Right now it's set at lanes. Lanes means it just goes back and forth over the part, and if it has a gap in between, it'll just continue on to that next area. We can also change this to regions. If I have this at regions, then it'll just mill out the region. If it sees another region, it'll just go back and forth on that region and then go over to the next region. Let me just go now into my links and change these back to exactly the way it was before. I'll have the spline, the large move go back to its clearance area. Run my calculation and then simulate the part. This time, and let me actually slow it down, you'll see that the tool going a little bit too quick. I'll go a little slower. You'll see this time it's going back and forth on any linear, but now when it gets to this area, it's staying on this region only. It didn't jump to the next region. Staying on that region, going across the part, and it did that for every single one of those areas, just staying on the region. Note the difference in machining time by doing it this way. Okay? Now, even if I kept it straight, going back and forth, let's put this back in the, go back to the toolpath parameters and put this back in lanes. And if I go up to my link area, change my large gaps over here to clearance area instead, let's see what happens now as far as time goes. First of all, you have all these jump ups, which is not really that great. And even time-wise, it takes more time doing it this way rather than doing it in the region. So in this particular case, if I were to use the option of linear, we can use the toolpath parameter of sorting by regions, and that'll actually take care of, give us a much better tool pass on the part itself, as shown over here. Of course, I would have my small gaps at the direct instead for any small gaps I may have over there, and it would give us a much faster machining time. Okay, that's as far as the option of linear goes. Now let's take another operation of HSS, and this time we'll take a look at what we call parallel to curve. Let's say, for example, I use this option and I want to machine this surface over here, okay? And I want to actually machine it parallel to this curve over here. What'll actually happen is I'll choose the edge curve as shown over here. I'll choose this curve over here, this one, that one over there, and that curve over there, as well as that edge over there. And that's the curve. In other words, it'll work on this surface according to the shape of this edge over there. It won't go parallel to Z. It'll actually go according to the shape as shown over there. Let's just accept that. We'll use the ball nose end mill. We have our toolpath parameters. We'll just leave it there right now. Let's see exactly what we got over here. Note, first of all, it's machining from the bottom up. So let's actually change that. First, I want it to work from the top down. So if I go into my toolpath parameter surface quality, in sorting, we have the option over here of flip step over, so we can flip the actual direction that we are machining in. Let's take a look again at the toolpath, and as you see this time, it's starting from the top, going according to the shape that we have over there. Now let's speed up a little bit, and look what happens when it gets to the bottom. When it gets to the bottom, since it's working on this shape over there, it gets to the edge, it has to go to the other area over there. So it's actually jumping out and going to its clearance area. So let's take care of that now in the links. If we go into our link, again, we can take care of that by saying, okay, link between slices. Let's actually blend them. Let's see what happens now. We will actually take a look at the simulation. Again, we have the exact same toolpath in the very beginning, but now look what happens at the end. It's actually now blending from one to the next, as shown over here. Okay, now, one thing though, we did not deal with at all, as far as how do I actually go into the surface and how do I actually leave it. Right now I went straight down into it, but I actually want to go into it in an arc from the side. Well, that is controlled by the approach and retract. Right now we have it, don't use lead in or lead out. Let's just use our lead in and use our lead out as well. Now let's run our simulation after I calculate. Notice the calculation is actually very quick. Let's actually go quickly over here, and you can see that we have our lead in using an arc, and we have our lead out using that arc there as well. One more thing though, however, with these, the way it works from one end to over here, I'd actually like it, as it leaves the surface over here, to actually leave the surface as an arc as well. So for that, since it's between the slices, we'll go into our link, and we have actually control of lead in and lead out between slices as well. Right now, it's don't use lead in and out. I actually do want to use lead in and lead out, and we'll use the actual default the way it's set right now. Sorry, let me do calculate, run my simulation, and this time, you can see at the very end, it actually takes an arc out, and then blends itself back in, and then going back onto the material using an arc. Okay, now we're going to get back to that surface in a moment, but now I'd like to go to my next option that I have in the HSS. If I were to open up HSS again, this time we have an option called perpendicular to curve. Hold on one moment, please. אני מבקש שקט פה, תודה. Okay, sorry about that. As I was saying, we're going to use the option of parallel to curves. Now, what I'd like to do actually is work on this surface as shown over here. Okay? And I'd like to work actually going up in this direction, back and forth on this surface. Now, the way we can do that is by using the option of parallel to curves. And if I were to go into my geometry, drive surface, I'll choose that's the surface I want to work on. And my edge curve is going to be this edge over there. So my toolpath is going to be actually perpendicular to that curve over there. Now, the tool that I will be using will be, again, my ball and mill, as shown over here. And again, we have our toolpath parameters. Let's just do it exactly the way we have it set up right now. And as you can see, it goes, let me do that actually very slowly. Sorry, I wanted perpendicular to curve. I took parallel to curve. So as I said, perpendicular to curve. Note the geometry. I'll use that same geometry I had before. If I'm not sure exactly which geometry it is, I can always go in over here and check the geometry out just by looking over here. I believe it is this one over here. Yes, it is. Save and calculate, run my simulation. This time, it's going up and down on the surface exactly the way I want it. Perpendicular to that curve. Now, note again with the lead in and lead out. There is no lead in and lead out. This time, however, when I do lead in and lead out, I don't want it to come in from the side. I'd rather actually come vertical from the top and arc in that way. So when I go into my links in my approach and retreat and use my lead in and lead out, this time I can actually go into my lead in over here. And instead of using the default, I can change that to vertical tangent. And I'll do the same thing for my lead out. Again, using vertical tangent. Run my calculation and my simulation, and you'll see this time it's coming in from the top and also leaving going up instead of going in from the side. Okay, going on to my next option that I have inside HSS. Excuse me. We have morph between two boundary curves. Now, if you remember correctly before, I worked on this surface over here, and I actually did it parallel to this curve. But when it got to the bottom, it kept on being parallel to that curve, and then you had these little jumps back and forth over there. What I'd like to do instead is use the option of morph between two boundary curves. What that would do is as follows. If I choose this as my drive surface, as shown over there, I'll choose my edge curve, just as I did over here, my start edge curve over here, these curves on top over there. Accept that. And then I'll choose a second curve, my end edge curve, and that would be actually the one I have at the very bottom, this one over here. By doing that, what's going to happen, it's going to start off working according parallel to this, but then slowly work its way into the shape that we have at the bottom. So if we take a look now, we choose a tool as I did before, my ball nose, levels, okay, and my toolpath parameters. Let's change my toolpath parameters to say 2.2 millimeters, and we'll be going zigzag back and forth. Running my simulation on the part. You see the calculation actually goes very quickly. You'll see that it's going according to the shape at the very beginning as it is on top over there. Then when I go towards the bottom, you can see that it's slowly but surely changing its shape to the way it's shaped at the very bottom over there, giving us a much better toolpath than I had before. Now, this option, by the way, is used very often on areas such as this as well. If we take a look at the part itself, you can see we have a radius going around the part. This is a perfect tool for working on these radiuses as well. If I, for example, go into my geometry, choose, let's just do part of it for now. I'll choose this arc, over that surface over there, that one, and that one over there. My start edge will be 1, 2, 3, and my end edge will be this one over here. this one and that one. Let's just run save and calculate, simulate, and you can see this time it's going perfectly back and forth. As of course, according to the as far as the ends goes over there, that's exactly between slices. So we have our links between slices. Let's just do it right now at direct. Sorry, let's do calculate. Run my simulation. And then we have the toolpath working exactly the way I want it on the radius. That's actually probably the best way. Many people use this just for those. Even on 2.5D parts, you'll find many people using actually this option for putting radiuses for machining the radiuses on the edge of the parts itself. Now, let me actually close this part and let me go to a part just like this one that I've already done all the operations, and we'll go through the operations that I've actually done over there. We'll open up that part, as I said. This one over here. And you can see I already have many operations. Of course, the first one, again, using the iMachining 3D, I've machined out that area over there, just like I had said I would. And now the next area was this area over there. I actually used, for this surfaces, since they were flat, I actually used linear on those surfaces over there, but only those surfaces. By doing that, I was able to use a tool that was a bullnose tool with a 10 millimeter end mill with a 1 millimeter radius. And then in my toolpath parameters, I was actually able to take bigger side steps of 3 millimeters instead of every 0.2 millimeters or 0.1 millimeters to get a good surface. This way I was able to get a nice good surface on the bottom, taking larger steps on that area as well. Now, going to my next operation that I did on this part, which was these surfaces over there. The way I did that was I actually took my option of perpendicular to curve. My geometry in this particular case were these surfaces as shown over there. I'll zoom in over there a bit. These are the surfaces that I wanted to work on. And I told it that I wanted to work perpendicular to this edge over there. So it's actually working perpendicular to that edge over there. In my toolpath parameters, we have our maximum step over. And note, in my sortings, I already have it set at working at regions as shown over there. Running the simulation, you'll see that I'll actually just go back and forth, working on the separate regions on the part. And then finishing off each region. Note, this surface I did not choose, so did not work on those surfaces at all. Now, I did another operation here as well for showing you a different way to machine these areas over here, these surfaces around over there. One of them, another way I did that, if I show you the toolpath working on this surface over here, was using the option of morph between two boundary curves, where my geometry was all of these surfaces over there. My edge curve, my start edge curve, was actually going from here around up until this edge over there. My surface going up until this point over there. And my end edge being this edge over here. So what the actual result is that the toolpath, in this particular case, is starting from one shape, as shown over there, starting from one shape over here. And then as it works its way around, goes back and forth, it slowly works its way towards this second shape over there, as shown over here. So that's also another way that this can be machined as well. Okay? Now, going to my next operation that I have over there, I worked on these edges over here. In other words, these radiuses that I have over there. And as I mentioned before, the way I did that was morph between two boundary curves, my geometry being these faces as shown over here, and the contour edges being the first one on top over there, and the second one on the bottom over there, giving us the exact same, exactly what I need as far as my finish goes over there, working exactly on those surfaces. Note, however, also that in my toolpath parameters, my sorting, I have it working one way on the part itself, instead of going zigzag. Since it's a closed surface already, I can do this working one way. Now, in my next operation over here, I actually work on these surfaces over here. For that, I also use the option of morph between two adjacent surfaces this time. The actual geometry was my drive surfaces were all of these surfaces around over there. My start edge surface was actually this radius that I used over here. I chose that geometry. In fact, I didn't have to choose create a new one. I just chose the geometry that I used in the previous operation as my start edge surface. My end edge surface in this particular case was the one at the bottom over there. And as you can see, the tool path that I got over here was a nice smooth tool path on this edge, going from one shape to the next shape as shown over there. Finishing off that surface really nicely, getting the exact shape I need without any kind of gaps on the part itself. Going further down into the part itself, we also machine this area over there using parallel to curves. And in this particular case, my geometry was very simply, this was my drive surface on the part itself, as shown over there. And my parallel curve, the inside edge over there. So work from the outside towards the inside edge, going around the part as shown over there. And basically you can see that I just about able to get to every single edge surface that I need to work on this area over there. Now, let me load a different part. And the next part that I'm going to load, I'm actually going to machine it from the beginning to the end. But we have specific problems with this type of part, which the only way to actually complete it is by using HSS. Now, the part that you're about to see on your screen is actually a simple part. What's the catch over here? The catch is as follows. If I zoom in over here, you'll note this surface over here, as well as these edges underneath over here, are actually undercut from the surface that's on top over there. Also, this surface over there actually has a little bit of a undercut as well. So those cannot be done using any of our other options, such as HSM or anything else like that. The only way to do those areas is by using HSS. Now, the part itself, as far as machining it out, I can use, as far as the roughing goes, I can use iMachining 3D. The actual finish on these surfaces over here, I can use even HSM. And in fact, I'll do that. I'll start off my first operation of 3D iMachining. I'll use my target, obviously, is automatically in there since I've chosen, my target is already defined. So it automatically loads the target. My tool will be a 8mm end mill, regular 8mm end mill. And of course, we have our technology wizard, everything's set over there. Our technology set over there. I'll just do the save and calculate over here. As it's calculating down and apart each level, going all the way down to the bottom. And now you can excuse me for a moment to give me a chance to actually wet my throat a little. Thank you. Okay, there's a little more involved over here, so it's actually the calculation takes a little longer over here, so we'll just be a little patient and wait till it finishes the calculation. As shown over here, it's now continuing down with the calculation on each Z level. If we take a look at the simulation, we'll use actually SolidVerify to see the simulation itself. You'll see in the simulation that, oops, sorry, I got to start it over here. Here we go. The simulation goes all the way down and does exactly what it was able to do. Now, there are areas where it couldn't get into, so all I'll do is do a quick save and copy, and then use a smaller end mill, say a 4mm end mill, and you do save and calculate again. We'll wait for the calculation again to finish. Now this time it's going to go into areas where the previous tool cannot go into, such as these areas down over there. It was not able to go into there, so it'll machine that as well, plus give it a little smaller steps so we'll be ready for the finished cut over here. Okay, it's doing its calculation like I said it would be. Just give it another moment or two and we'll be done with the calculation. And then we'll run the simulation. Excuse me. Okay, by the way, again, with any part that you have, even a prismatic part, as I did in my last webinar last week, one of the quickest way to just for programming it is just simply by using iMachining 3D, just to take out all of the excess material. It works a lot very quick. One operation, you can do all these, one or two if you need whatever rest machining that you may need over there. But it's very easy, and you get the most efficient tool pass because it's using the iMachining tool pass to machine that out. Okay, it's continuing its calculation as it goes all the way down. And in a moment, we'll take a look at the simulation the moment it finishes its calculation. Excuse me. Okay, we're almost done now. Now it's completing its steps. Let's take a look again at the simulation. This time, as you see, it's running only in the areas where it needs to finish over there. Take a look at it using SolidVerify. Let's actually take a look at it all using SolidVerify. As I start the simulation, you can see that goes down. Now the second tool is doing the rest machining, doing those smaller steps in those areas over there, and also working in areas where the previous end mill could not work because it was too large to get in there. Okay, so we're just about finished now. Now let's start our finishing operations. And as I said, this area I would like to actually do using HSM, just to show you that, I can use a regular HSM part, but even using HSM, there's certain areas I could not machine, just like those undercuts. So I'm going to start an HSM operation this time. And I'm going to use the option, if I look from the top over here, I'm going to work inside this area over here. I want to use actually doing radial cuts on the part itself. Shall use the option of radial machining. Again, we have our target. Our tool is going to be the ball end mill that I have over here. And my constraint boundaries is actually going to be, let me actually create a new constraint boundaries to show you exactly what I'm talking about. I'll be using these areas over here. Those are the surfaces that I want to work on over there. So I'll choose them as shown over here. These are the surfaces I want to work on. You just turn the part around. Choose the surfaces again. Now, even if I choose this surface, okay, even if I choose to work on this surface, it'll only go as far as it can go and not actually machine the bottom over there because that's an undercut and it will not be able to reach that part over there. Let's just accept that. Say okay. We'll have our passes. Let's set our passes at 0.2 millimeters. Just run our calculation. Let's run our simulation looking at the top view over here. And as you'll see, it's doing a nice radial cut on those surfaces over there. Okay, obviously there are areas that cannot be machined, such as these undercuts over here. So for that, we're going to actually start using our HSS options. Okay, so we'll start with our HSS. And the first HSS operation I'm going to actually use over here is going to be parallel cuts constant Z. The geometry in this particular case will be this surface here only. And obviously I need a tool that will able to work on the undercut. For example, the tool that I will use in this particular case will be a slot mill. And this particular slot mill that I'll be using actually has a radius at the very bottom, as you can see over here. That's the kind of slot mill that I'll be using on the part itself, as shown over there. We'll select that. Levels going down, toolpath parameters. Let's have a pretty small step down at 0.2 millimeters. We'll have a lead in and a lead out. And let's just run our simulation. And as you can see, we have a nice toolpath going around. Of course, we have these areas over there. I'll just take care of those gaps by going to my link. Have my gaps go follow the surface. Again, calculate and simulate. And this time, you see we have a nice toolpath at the very edge over there. Now, as far as the next area goes, these areas, that's a different story. I have to use a different type of a tool. And the type of tool I can use over here is what we call a lollipop tool. And what I'm going to do is actually we'll start doing it. I'm going to use the option of morph between boundary curves. Now, the geometry will be as follows. I'll choose these surfaces over here. I won't forget that I still have these surfaces over here as well that have to be machined, as well as this surface over there, that over there, and this over there. Did I forget anything? Of course, I forgot this. So we have all of the surfaces as shown over here. That's all pick. Now, the start edge will be, zoomed out a little bit zoomed in a little bit too much over here. As I said again, this is my edge I'll be working in. So my start edge is going to be starting from over here. So let me go to start edge. I'll start from this edge over there, going down this edge. I already picked that entity. Let me zoom in over here. choose that edge over there, as well as this edge over there. So we've picked that edge over there. We're all set for as far as that edge goes. The other edge that I want to pick, the end edge, is going to be this one over here, starting from here, going down the edge, just like I did on the other side over there. Picking this edge over there, as well as that edge over there. We're all set as far as that goes. Now, we'll choose a tool. And as I said, the type of tool I'll be using is what we call a lollipop tool, a tool that's shaped like that. We have our toolpath parameters. Let's do a small step over, let's say, of 0.2 millimeters. And let's run our calculation and simulate. We'll zoom out over here. And as you can see, it works exactly on that surface, taking care of the undercut as well. You can actually see the toolpath curving out inside that area over there. Now, I did this on one area, but I really need to do it on all 10 of these. Now, since this is symmetrical, all I have to do in this particular case, instead of choosing each one of those, I can go into roughing and more. We can go into rotate and translate. And by using the option of rotation, I'll just say I need a total of 10 steps. And my rotation angle will be 36 degrees. Let's run our calculation and simulate the part. And as you can see now, it's doing every single one of those. And so I did not have to choose every single one. I just did one, and it automatically rotated around on every single one of those surfaces. So what was nice about, specifically important about this part, is to note that we use this for undercuts. That's something you can't do with HSM. You can't do that with any other module. The only one you can use that with is with HSS, especially when I'm talking about now, obviously, is a 3-axis machine. 3-axis machine, the only module you can use for doing that is HSS. Okay. That's basically it for the webinar. As I said, the webinar has been recorded. I don't see any questions. So I'd like to again say thank you everyone for joining the webinar, and have a happy holidays, whether it be Christmas and for New Year's as well. And see you on our next webinar in another 2 weeks. Take care, everyone.